Hello there, this is a video about correlation. Now, correlation is something you saw a lot of at GCSE, so this won't be necessarily that difficult a topic. And certainly over the years, what's required on the new A level, linear A level for A level maths, um, there's less required about correlation than there used to be. Certainly, you don't need to find the correlation coefficient now. The posh name for it is this Pearson's product moment correlation coefficient, which is a bit of a mouthful. So this thing down here, this Pearson's product correlation coefficient. Now, Pearson was a statistician from, I don't know, 100 years ago, maybe 50 years ago. It's relatively new maths. And he came up with this idea of quantifying correlation. So we're going to look at it here today. Before we get started, there is a starter. And it's just really, I suppose, to make sure as part of what we're doing that you know how to use your calculator. So I just want you to find the mean, the standard deviation, the variance of those heights that I've given there. What's it say? It says there's 8 adult male soldiers were measured and their height was recorded. So you should know, and just in case you don't know, I'm going to tell you, on the Casio Class Whiz at least, you press menu. Now menu, if you're not sure where it is this button here. And once you press menu, you press number 6. And number 6 lets you effectively enter these numbers. So before you can do it, you have to press 1 and 1 variable. So I'm just writing this down now, just in case you didn't know. And then you've got a bunch of numbers that you can type into underneath the X number. So I'm going to type them in 181, 160. You should do the same. Perhaps pause the video whilst I'm typing them in, and that way you can get your answer at the same time as me. And I'm nearly there. Okay, I've typed all mine in, so if you don't want to know what I got, you can pause it. At this point, I would press Option. It's OPTN, and it's this button here. And when you press that, again, you then press number 3. Which is, it says 1 variable calculator. Well, technically it says 1 variable calc. So I'm going to press number 3, and it comes up with a whole load of stuff. And so one of which is the mean, and you should know by now, the mean actually says X bar, a little bar across the top. And on my calculator, that's 177. Now it says to 3 sig figs, so that is right to 3 sig figs. It actually says 0.125. What else does it want? It wants a standard deviation. Well, the standard deviation, you should know, is the symbol that says sigma x. On my calculator, it says 9.649, so I'm going to say 9.65. And the third and only last one I want, it says variance. So the variance, again, need to know which one it is. It's sigma x with a square, because the variance is the square of the standard deviation. And again, the good thing about this is you don't have to type it in. It says 93.109. So I'm going to write 93.1 to 3 sig figs. See if I get those right. Yes, I did. So those I'm happy with. Now, let's do the main lesson today. This is all about correlation. Correlation, then, you saw at GCSE. And at GCSE, you basically had to describe the type of correlation you got. So that's what this is. You are meant to know, for instance, that this, because it's going upwards, is positive correlation. You're meant to know that this is negative correlation because this one's going downwards. And you obviously from left to right. Now this one kind of is all hickledy-pickledy. So I would describe this as having 0 correlation, or perhaps no correlation. Now this one is, well, I think it vaguely is going upwards, but it's not very strong correlation. So I would say this is weak positive correlation. And that straight away that implies that I could have described these as strong correlation perhaps, and strong negative correlation. So just be aware that you get at GCSE this idea of positive or negative or 0. And then strong or weak or moderately strong, or some description of wordy. Strong positive correlation, strong negative correlation, no correlation, weak positive correlation. So I agreed with what I decided it was last time I looked at this slide. Now, what is correlation then? This is a way at GCSE we described the relationship between two variables. Positive means it's going up, negative means it's going down. But at A level, we need more than that. We need to try to put a number to it from 1 to -1. And this is the new thing that we do at A level maths. And so I've made up some numbers here. If I had, for instance, correlation of 0.9, I would, because it's very close to 1, you can see 1 is the maximum. You can't get above a 1. So the closer you are to 1, the stronger the correlation is. So here it's 1 is as good as you can get. 0.9 there is really close to it. So this would be described as very, very strong positive correlation. Whereas perhaps a figure of 0.42, you can see it's positive. It's higher than 0. It's a plus number. But again, this in the middle, you describe this as 0 correlation. So this must be pretty close. This is 0.42. I would probably class that as weak positive correlation. Whereas this, it's practically 0. It's so close to 0, I would call it 0 correlation. And this one here, -0.81. Well, again, this is as low as you are able to go with correlation, -1. And this is pretty close to it. So I describe that as strong negative correlation. And of course, I've made up these numbers. It could have easily been -0.83 or something. It's not meant to be an exact definition. And notice this, we use the letter R for the correlation coefficient. And this is sometimes called Pearson's product moment. Now, there's a bit of a horrible name, I'll tell you now. Product moment correlation coefficient. And correlation, I think I spelled that right, coefficient. So it is a bit rubbish. I mean, I very often write it as PPMCC for that reason, or so perhaps you might see it just Pearson's and then described as the PMCC. And of course, the symbol for it is R. Lowercase r as well, not a capital, lowercase. And so, which of these match those there? I suppose we've got 6 correlation coefficients I've got over here. And one of them is for each one. Which one do I think? Now, first of all, the easy ones are the ones which are exactly 1 or exactly -1, or is exactly 0. So I think this is the 0.01, because you can see there's no correlation there. I think this looks to me as if it's on a perfect straight line. And when it's on a perfect straight line, R will equal exactly 1. They've written 1.0, so I'll do the same. That was 0.0 because it has 0 correlation. What else have we got? We've got a 0.9. Now 0.9 is still positive, it's still going up, it's just not quite so perfect. I think that fits the bill. R equals 0.9. What else we got? We've got a -0.9. Where's that? We need one going down like there. You can see it. It's not perfect. It's not exactly in a perfect straight line, but it's not far off. I reckon that's R equals -0.9. What else we got? Oh, we've got a 0.5 and a -0.5. Well, presumably this is the 0.5. And this one is the -0.5. And is the direction of the line, tells you if it's positive or negative. That exactly agrees with the things that you were doing at GCSE, where you described it as positive or negative correlation. But now we put a number to it in terms of how strong it is. Now you might be wondering, where do you get these numbers from? Well, at A-level maths, you don't really ever need to know. You can get them on your calculator as it happens. Your calculator will be very happy to tell you what they are. If you type the numbers in, you know what to do. But for A-level maths, you don't need it. You will just be told in your exam, here is the number, tell me something about it. So let's get used to that. We don't really need to know where it comes from. We just need to know what to do when we get it. And hopefully my numbers there, just quickly scanning them, yes, they do agree with what I said. So how do we interpret these correlation coefficients? Well, we've got to be a little bit careful, because just because two things are correlated does not mean that one caused the other one to happen. And we tend to say this in terms of this famous phrase, correlation does not imply causation. Causation coming from the word something causes something else to happen. So just because something is correlated does not mean it causes it to happen. So here's an example which I thought of. One example to show this might be the more firemen that are sent to a fire, the more damage it is done. Now, if this is probably true, the more firemen are sent to a fire, the more damage is done. Now, that is probably true, but if you think about it for a moment, why would that be the case? Well, you send lots of people to a fire to put out big fires. So there will be lots of damage done when there's a big fire. So you can see that just because this happens does not mean they cause it. No, they don't cause it. Here's a second example. It says if you only... Oh, sorry, it's not the second example. It's a second problem. If you only have a small sample, you might find that you get slightly dodgy results. It says, for instance, if you only test 8 people on their TV watching and their test scores, it's difficult to conclude that, for everyone in the country, if you like, that people who watch lots of TV will definitely get a poor grade. It might be true, it might not be true, but you've only tested 8 people, so don't suppose for a moment that your sample's good enough. So that's 2 possible problems regarding correlation and interpreting your answers. Both of them are potential questions in your exam. Now, this is another type of question. So this is, I'm giving you the actual numbers here, but you don't need them. What's it say? It says the data below was used to find the correlation coefficient for the length and width of broad beans. Presumably these are the broad beans. It was found that the correlation coefficient was 0.898. Now, straight away I'm thinking that is close to 1. And it's close to positive 1, actually. So explain what this tells you about the correlation. I would describe this as a very strong correlation. Why very strong? Because it's really close to 1. Very strong positive correlation. And you'll need to probably write that it's not only very strong correlation between, what is it? It's the length and the width of these beans. So I'm going to write length stroke width. I think you should say some context in the question of the beans. There you go, the broad beans, I suppose. So a gardener says this means that broad beans, heavy broad beans, there you go, make them longer. Is she right? Well, possibly, but possibly not. So I would probably say here, not definitely correct. And my stock phrase I'm going to write is, I'm going to say correlation does not, and I want you to learn this phrase, does not imply causation. Just because it happens doesn't mean it was caused by it. Learn this phrase. Correlation does not imply causation. So that's what I would say. In fact, that's what I wrote here as well. Other factors may need to be considered. Also, the sample size is very small. I think that's all very good reasons. Here's another example. Now, it's the distance in miles that people live from London, it says. And it's the percentage you work from home. Now, this was probably pre-COVID. I bet these numbers are massively higher now. But never mind, let's look at the data. The product moment correlation coefficient for this data is minus 0.297. What does this tell us? Well, it's, I suppose, some evidence, and it's only some evidence, that there might be a link. Do you know what I mean? Don't be too definite when you say these things. There might be a... the posh word for a link is an association. There is an association, but I probably also should say it's a negative association between the distance that you live from London and your chances of working from home. I.e., if you live a long way from London, it's smaller. Actually, I should probably say there is some weak evidence. Because it is only a small number. That's the other thing I would say. It's minus 0.297. It's not strong evidence, is it? Now, you'd probably just say it's weak negative correlation. That's what we would have described it as at the start. And you get this all from this number being closer to 0, really, than it is to 1, or minus 1 in this case. So, look, that's probably going to be as much as I do here. That will be good enough. And in class, we'll have a crack at doing some of these questions and just showing that we understand exactly what we need to do. So in class we'll do exercise 16D, and 16D, as I say, page 345 in this textbook or whatever textbook you're using. All the best.